Good morning, students. Today we will discuss about the DC-DC converter. In the previous class, we will discuss about the RMS values. So today in this class, we will discuss about the DC-DC buck converter. So just okay, I'll write down all the necessary points in this slide. So there are basically three types of the DC-DC converter circuits, termed as the buck converter, boost converter, buck boost converter. So what is common in between all these circuits? That all of these circuits use their power devices. Power device as a switch. Power device can be power diode, can be a thyristor, can be a power MOSFET, can be a BJT. So you can use any of the power devices. Taking the benefit of these power devices, you can build the buck converter. Okay, so what is the significance? Yeah, what is the meaning of buck? The buck means step down. Buck means step down. It's a step down converter. It's step down the voltage. Okay, output voltage is always less than the input voltage. The efficiency of the buck converter is very high. This is up to 90%. So basically, the application of the buck converter is mainly used in SMPS circuit, that is the switch mode power supply. Apart from this, it is used in the CPU, that is you have a 12 volt supply by the SMPS, and then you have to give the supply to the USB, DRAM, CPU. All of these devices are working in the different voltages ranging between 1.8 volt to 4.2 volt. So basically this is step down converter. What means step down? Okay, so what is the circuit is consist of this one high voltage PS, one switch, one freewheeling diode, this is our power diode, this is inductor L, capacitor and load. Output is taken across this load. So let us assume the first case. The first case is when your switch S1 is on. When your switch S1 is on. So when your switch S1 is on, what will happen? The switch is closed, the supply is connected to the whole circuit. This is freewheeling diode. It's reverse bias. You can see that this is reverse bias. This inductor, this is capacitor, and this is your load. So capacitor is storing. Capacitor is the energy element. Capacitor and inductor are the energy element. So these will store the charges. So L start charging because L stores the energy. So during the positive first cycle, when the switch is on, the inductor is the main power source that is storing the element. What and current? If I assume there is the current is going from this source, going through this inductor. So they are split in between capacitor and the load. The current amount of the current in the capacitor is very less as compared to the output load. We will discuss this later also, but why? It's a very common sense thing. Why the capacitor, the amount of the capacitor is the amount of the current in the capacitor is very less, because it's a DC supply. Capacitance, the reactance is given 1 upon j omega. C omega is, for the DC case, the omega is 0, no frequency element. It's a constant current, no frequency, then 1 upon 0 equals to infinite. So it will behave like an open circuit. So this and this, these two behave like open. We will discuss this later also. So very partial current is flowing in this capacitor through. Maximum current is and across the load voltage V out, load output V out. Okay, this is your first case S1. So now second case, S2. When your switch is off, when your switch is off, then what will happen? This is the energy element. This store the energy during the first cycle. During the on duration, this store the energy. So what will happen? Now this time it will release the energy. In the next half cycle, means in the next thing it will release the energy. First it stores the energy. Now it's releasing when the polarity will shift. This will be like positive. This will be like an negative. This diode will be in forward bias. Again, this is very partial current flowing through this capacitor and maximum current is going through this load. So this is how it works in the off condition when your switch is off. So move to the next. Now the waveforms. What are the waveforms? What are the output waveforms? So to discuss the output waveform, first of all, let us assume that the supply voltage is producing a current of I in, I input current, this is diode current ID, and this is your load current, sorry, not load current, this is your inductor current IL, this is your IC, and please write this as a I naught, write this as a I naught output current, otherwise we will mix, please write this as I naught. So what, so your this your output voltage, okay, write is for the T on period, T off on period means when your switch is on, you will get the output. Your switch is off, your switch is on, your switch is off. So this is your, okay, this is how you get the waveform. So what will happen in the load current, that when your period is on, your T on your I in is supplying the current. For the T of I is not supplying the current, again T on the I in is supplying the current, and T of the I in is not supplying the current. What is happening to the diode current during the first cycle, that is the on period? On period, your diode is reverse bias, so it will not conduct. During the next cycle, that is T off cycle, it will conduct. It will start conducting. So amount of the current start conducting. Okay, like this. Next off cycle, again diode is reverse bias is off. Next is again it's on. So that is how your ID will behave. IN and ID. What will happen to your inductor current? Your inductor current, this IN inductor current. First of all, start this start storing the energy means start charging. Start charging from the I minimum is required. I minimum is required. Start charging for the T on period. And what will happen for the next cycle? That is switches off. Then it start releasing the energy. Is releasing the current. Then it's charging. Then releasing the current. Similarly, what will happen to your this IC? The amount of IC is very less, so the average IC is coming out to be 0. So this is like something like this. We will prove this again later. Okay, that is the output waveform of a buck converter. Let us move forward. Now consider a case, the on condition. What will happen in the on condition? During the on condition, the switch is on. During the on condition, switch is on. Supply voltage is directly connected. There is a flow, the current flow circuit is working. Is only this freewheeling diode is not not connected to the. Then this IL, IC, I naught, IL, IC, I naught. So for the on condition, the T on, for the period of the T on, if we can see that the voltage across the inductor on voltage is what? Supply voltage minus of naught. Very easy. There is no drop across here. No drop across here. This equals to 0. So BL on equals to BS minus of B naught. Okay. What is IC on? capacitor current IC on during the on period. It is what this is IL incoming current equal to ID in all incoming current equals to all outgoing current. Simple KCL Kirchhoff current law. So IC on equals to IL minus I naught. Simple IL minus I naught. For the second case, that is the off condition, the switch is off, but this circuit is just be disconnected from the input. And similarly, you can find out that polarity is changed. So VL off equals to minus of this is plus, this is minus, this is entering the current plug, this is minus. So VL off equals to minus of V out. And IC off is again IC off will be similar IL minus of I naught. So using the voltage second balance across the inductor, the VL on multiplied by T on plus VL off multiplied by T off equals to 0. This is voltage second balance. Voltage second balance. So just put all the values from the above equation. The voltage VL on is given by this, VS minus V out, IC on is given by IL. All the values are put. What is T on? Is the on period. On period is given by the duty cycle. We know that we have already done in previous class about the duty cycle. The duty cycle is given by the T on upon T, total time. Okay. So your T on is given by D into T. So just put the value D into T here also. T of is 1 minus D, 1 minus duty cycle into T, 0. Solve it, you will get output V of is equal to D times of Vs. That means your output voltage is always less than the input voltage by the factor of D. The value of D is range between the 0 to duty cycle range between 0 to 9, 0 to 1, minimum 0, maximum 1, 100%. So for this case, but converter if our efficiency is 90%, then the duty cycle is 0.9. So your output voltage is 0.9 times of input voltage. So this is Buck mode of conversion. That is your output voltage is always less than the input voltage. Next, that is now we have to prove that the current across the this capacitor is 0. So for this purpose, the ampere second balance law, that IC on multiplied by T on plus IC off multiplied by T off equals to 0. And you put all the values together from the above equations, you will get that your load current is equal to the out your IL. IL is equal to the I naught, means your current inductor current is equal to the output current. That means there is no current flowing in the capacitor. There is no term of the IC. Total current reflected emerging from the inductor is passing through the load. So capacitor does not flow any current, and we prove that the average DC current in capacitor is 0. And you also know that the capacitor is in capacitor reactance is given by 1 upon J omega C. For the DC current, the frequency is given by 0. Frequency is 0, so 1 upon 0 is infinite, and we already proved it. So this is what the so that's is what we learned today. We learned about the buck converter, but basically using the CPU. That is switch mode power supply. This is the basic circuit diagram. Exact diagram consists of the power diode, okay, L and C connections. So we have seen then the two operations, that is switch is on and switch is off. And for the both cases we have solved. First of all, we analyze the waveform. We get the waveform, and after getting the waveform, we analyze analytically that the analytically the output voltage is always less than the analytically the output voltage is always less than the input voltage by the factor of the value of the range between 0 to 1. For the buck converter, the efficiency is 90%, so the value of D is around 90%. And finally, we prove that the current flowing across the capacitor is 0. So this is the buck mode of conversion. Thank you guys. Thank you for your patience.